The concept of testing for independence is usually pretty challenging for students. So let's look at another example of independence and explain what independence is and then how you test for it. So let's say we have two variables. We'll say one variable is the favorite flavor of ice cream. So let's say here we have chocolate and vanilla ice cream. Kind of boring, but we'll go with that. And then we have, let's say, children, and we'll define children as like say 12 and under, less than 12, 12 and under, and we'll say teenagers, okay, teens, all right. Now we want to know, is the flavor of ice cream dependent on the age of the student? Okay, so we got children and we've got teens. So let's say we have 100 students, and of the 100 students, 60 of them like chocolate and 40 of them like vanilla. And let's say in our sample here we have 48 children and 52 teens. Okay, and actually I'm going to change these percentages to make this just a little bit easier for our example. Let's say that 75% like chocolate and 25% like vanilla. So 75 of the 100 students like chocolate and 25 like vanilla. 48 of the children, 48 are children, 52 are teens. Actually, I'm going to change that again. Let's just make this a little bit more interesting, a little more extreme maybe. Let's say we just have 20 children and we have 80 teenagers in our sample. Okay. Now, if flavor of ice cream preferred is independent of age, what would we expect to see the numbers in the middle columns to be, in these middle cells to be? So 75% like chocolate. So if there is no relationship between age of the student and the flavor of ice cream, we would expect 75% of the teenagers to like chocolate, or 60 out of the 80, and then 20 to like vanilla. And we would expect 75% of the children, or 15 out of the children, and 5 to not like. So notice how that adds up really nicely. 15 and 60 is 75, 5 and 20 is 25. So we would say something like the probability that you prefer chocolate is 75 over 100, which is 0.75. The probability that you prefer chocolate, given that you're a teenager, is 60 over 80, which is also 0.75. The probability that you prefer chocolate, given that you're a child, is 15 over 20, which is also 0.75. Since probability of liking chocolate is not changed when you split it by age, okay, since all three of these are equal, ice cream preference is independent of age. Okay, because it doesn't matter what age you are, 75% of everybody likes ice cream. Now let's look at an example where things are not independent. So let's just use our same example, and let's say that we'll look at under 18 and over 18. Okay, so like minors and adults. And let's go with the same ice cream flavor. So we have chocolate and vanilla. And we still have 100 people. Get my totals down here. We still have 100 people. and let's say we have 50, no, let's just say 60 that are under 18 and 40 that are over 18. And let's say that we end up with 50 who like chocolate and 50 who like vanilla. Now, if they were independent of each other, the age and the ice cream preference, ice cream flavor preference, we'd expect this to be 30-30 and 20-20. But let's say this is 10 and, no, let's make this, I'm going to make these easy numbers to do, 15 and 45. And let's make this, then this would have to be 35 and 5. Okay, notice once I pick these two numbers, I had to have these, all right? So what I could do is say the probability of preferring chocolate is 50 out of 100, which is 0.5. The probability of preferring chocolate, given that you're less than 18, is 15 out of 60, or 0.25. The probability that you prefer chocolate, given that you're greater than 18, is 35 out of 40, and I don't know off the top of my head what that is, so let me do that. 35 divided by 40, 0.875 is 0.875. So since probability of chocolate is not equal to the probability of chocolate given less than 18, and it's not equal to the probability of chocolate given greater than 18, then ice cream preference is not independent of age. As a matter of fact, we could say in our sample, in this sample, older people prefer chocolate more than younger people. Okay, so there is a distinction. If we know the age, then we know that the chocolate preference changes, or the ice cream flavor preference changes. So hopefully this will clarify a little better what is meant by independence, and that'll help you with problems where you have to prove independence. So just to remind you, if you're asked to demonstrate whether two things are independent, you have to do three things. You have to compare a conditional and non-conditional probability, or two conditional probabilities. Okay, so notice I could compare the chocolate preference to the chocolate preference given less than 18, the chocolate to the chocolate preference given greater than 18, or I can compare these two chocolate preferences less than 18 and greater than 18 to each other. Notice though that each one has to have chocolate as the main thing I'm comparing, with just different given information. Then you have to state whether or not the probabilities are equal. Okay, if they are not equal, you have to specifically show this. You have to refer to that and then say, since equal, or since not equal, then independent or not independent. So those are what you have to do. You have to compute the appropriate probabilities, and then use the fact that they are equal or not equal then to support your reasoning for independence or not independent.